Hey everybody, Dan Huot here, still in the space vehicle mock-up facility. I'm back at the Orion capsules as they're continuing their crew egress fully suited runs, doing some tests today on a lot of the systems inside. Joining me now is Dustin Gohmert. He's the Crew Survival Systems Manager here overseeing the test. First off, thanks for breaking away for a few minutes from the test and coming over to talk to me. Now, Crew Survival Systems Manager, you're looking over everything that's keeping the crew alive inside this thing.
That's pretty much correct. So everything that the crew touches, wears, does, sits on, interacts with, that keeps them alive in normal situations and emergencies we work on. So our main hardware that's easy to speak of is the seats, the crew survival equipment that they would use. So this includes things like the life rafts or their life preserver units, or even things like signal flares they would carry with them post-egress. And then also the spacesuits, which would be used in particular contingencies for cabin emergencies and space vacuum.
Okay, so we had talked to Jeff Fox a little bit earlier about the seats. They're changing the seating arrangement up and a lot of things like that. Now, as crew safety, what's your involvement with the seats? What are you guys looking at? What are you concerned about?
Right. So specifically, our group is involved in the design of the seat itself, but you can't design the seat without having some knowledge of its interaction with the vehicle. And so we're here today looking at how the vehicle is placing the seats within itself, or how we're placing the seats within the vehicle spacing, to understand what design tweaks we need to make to keep the crew safe, how the acceleration loads that are imparted on the vehicle will be transferred to the crew so we can properly design it for their safety. In addition to that, we're also looking specifically today, when we design it for landing safety, we can't only consider that, we have to look at the entire breadth of the scenario. So post-landing egress, if there's an emergency, for example, how do they get out of those seats to get away from the emergency scenario? So we don't want to solve one problem and induce another, and that's why we do as many tests as we do.
Okay, and one thing that we learned earlier was the fact that the crew is fully suited. I mean, that's a pretty special occasion for a lot of these test guys. What kind of suits are they wearing today? They look very familiar.
Yes. They should look familiar. They're either specifically from the shuttle program or modified versions of the advanced crew escape suit that we used in the shuttle program. And we were very fortunate when the shuttle program ended. Our team inherited all of the suits we flew in the shuttle program, and we're actually working to repurpose them for Orion. So the shell of them is very much the same, and to a casual user you may not even know the difference. But internally we modified them to work with the, call it plumbing, that's inside Orion to provide them air. It's very different than it was in the shuttle.
And we got some video of Rex Walheim in the Neutral Buoyancy Laboratory testing out one of these suits. Now, during the shuttle days, this was just kind of a launch and entry suit. What are some of the things it's being designed for to be potentially used in Orion?
Well, its primary purpose still is that of a launch and entry suit. And when you talk about a launch entry suit, our big factor is keeping the suit as a fully soft suit so that the interface between the person and the seat is non-injurious in that landing impact. But what we're trying to expand it to in as Orion is contingency, and maybe even beyond contingency, for limited capacity extravehicular activity. So think about today we use the white EMU, the extravehicular mobility unit, very big. That suit is as big as it is because it has lots of rigid mobility joints. This suit doesn't, again, because it's designed primarily for launch and entry. But what we're trying to do is learn a little bit more how we can effectively use it for EVAs. And really what it goes back to is more like the days of Gemini when we were first learning. And that suit that Ed White wore, for example, is, say, the first cousin to this suit. Very, very similar construction. And so we're stepping back to some of our heritage to be able to use one suit for multiple tasks.
Are there any specific upgrades you're building into the suit?
We don't want to limit ourselves any more than we have to, so there are certain design features that we're considering adding to this suit. The testing you spoke of at the Neutral Buoyancy Lab with Rex Walheim is an example. We're learning what features we need to add to the suit to enhance its mobility. That test was just a first cut. Here's the baseline suit, let's learn how it performs. In future tests we'll be performing over the summer, we'll be adding things like enhanced gloves, enhanced mobility elbows, and perhaps even bearings in the lower arms to enhance flexibility of that joint. All the while keeping in mind, how does this suit have to keep its heritage for launch and entry safety? So none of the things that we add can compromise a safe landing, because we have to launch and land every time. An EVA may be a more rare case. So it's a balancing act for us.
Okay, well, just some of the more exciting upgrades coming out of the Orion program, not just the vehicle, but the suits themselves the astronauts will be in. Dustin, thanks so much for, again, taking a few minutes. And
thanks for having us.